Hi students, it's Dibyendu. Today I want to discuss an important chapter of class 12 for all boards. The name of chapter is D block and A block elements. So students, please follow my instructions carefully. Today I want to discuss some important questions of DNA block elements. So students, please read all the questions carefully. I think these questions are very helpful for your board examination. So let's start. Question number 1. Zn plus 2 salts are white while Cu plus 2 salts are colored. Why? Answer: Zn plus 2 ions have completely filled d subshell, means have no unpaired electrons. Therefore, Zn plus 2 ions are white. Okay, that means Zn plus 2 has completely filled d subshell. That means no dd transition takes place. That's why Zn plus 2 salts are white while Cu plus 2 salts are colored. Question number 2. Why do transition elements show variable oxidation state? Answer: Ns and N-1d electrons of transition metal participate in bonding, which results in variable oxidation states. When Ns electrons take part in bonding, they exhibit lower oxidation states, whereas when N-1d electrons along with Ns electrons participate in bonding, they exhibit higher oxidation state. Okay, that means transition element contain Ns as well as N-1d electrons. That mean there are two possibilities. That means Ns as well as N-1d electron can participate in bonding. That's why it shows variable oxidation state. Question number 3. Compounds of transition elements are often colored. Why? Answer: most of the complexes of transition elements are colored. This is because of the adsorption of radiation from visible light region to promote an electron from one of the d orbitals to another. The ions of transition element absorb the radiation of a particular wavelength and the rest is reflected, imparting color to the solution. Okay, question number 4. Assign reason for the following. Copper 1 ion is not known in aqueous solution. Answer: Copper 1 ions are unstable in aqueous solution and undergo disproportionation reaction. That means intermediate oxidation state to higher and lower oxidation state. That means to Cu plus it gives Cu plus 2 plus Cu. The stability of Cu plus 2 aqueous rather than Cu plus aqueous is due to much more negative delage hydration of Cu plus 2 aqueous than Cu plus. That's why copper ion is not known in aqueous solution. Question number 5. Transition metals and their compounds generally exhibit a paramagnetic behavior. Give reason. Answer: paramagnetism arises due to the presence of unpaired electrons. When transition metal ions have unpaired electrons in d orbitals, that means from d1 to d9, they exhibit paramagnetic behavior. Okay. Next question. Assign reason for the following. Transition metals and many of their compounds act as good catalyst. Answer: transition metals show variable oxidation states, form unstable intermediate compounds, provide a new path with lower activation energy and have vacant orbitals. Therefore, these are good catalysts. Next question. Explain the following observation. The transition elements have great tendency for complex formation. Answer. Due to comparatively smaller size of the metal ions, high ionic charges and the availability of vacant d orbitals for bond formation, transition metals form a large number of complex compounds. Okay. Next question number 8. The enthalpies of atomization of transition elements are high. Explain. Answer. Transition metals have high enthalpies of atomization due to strong metallic bonding and additional covalent bonding. Metallic bonding is due to their smaller size while covalent bonding is due to DD overlapping. Number 9. Account for the following. A transition metal exhibits higher oxidation states in oxides and fluorides. Answer. If is the most electronegative element. The transition metals show highest oxidation state with fluorine. The tendency of fluorine to stabilize highest oxidation state is due to its highest lattice enthalpy, as in case of COF3, or highest bond enthalpy due to higher covalent bonds, as for example VF3 and CRF6. Ability of oxygen to stabilize these high oxidation states exceeds that of fluorine, as for example Mn forms the highest fluoride as MnF4, whereas the highest oxide is Mn2O7. This is due to the tendency of oxygen to form multiple bonds. Next question. Although CO plus 2 ion appears to be stable, it is easily oxidized to CO plus 3 ion in the presence of a strong ligand. Explain. Answer. Electronic configuration of Mn plus 2 is 3d5, which is half filled and hence stable. Therefore, third ionization enthalpy is very high. That is, third ionization enthalpy as third ionization enthalpy is high, that is, third electron can't be lost easily. In case of Fe plus 2, electronic configuration is 3d6. Hence, it can lose one electron easily to give stable configuration, that is 3d5. Okay. Hope students, these questions will be very helpful for your board examination. Please read all the questions carefully. If you like my video and want to uploading videos like this, please subscribe my channel and hit the like button. Hope